So another example of a class that you can extend in UnrealScript is the Kismet related classes. You're probably familiar with Kismet as the higher level scripting language, the visual scripting language that is available in the Unreal editor. And so one of the great things about UnrealScript is not only can you write your own custom object types that can be placed in the editor and used in your levels, as well as do AI logic or weapon logic. So you can really kind of shape the whole game from UnrealScript, but you can also alter the Kismet environment for your project and add custom functionality. Examples of when you'd want to do this would be as if you add your own custom object type, for instance, say a custom trigger or custom mesh type, that you would then need to be able to manipulate that from the game environment while the game is running, while Kismet is running at runtime. And so you could write a custom Kismet action or event that would coincide with that object that would allow you to reference that from your level scripting. So anyway, I wanted to go over quickly how you set one of those up. Infringe makes that, the IDE that we're developing in makes that easy to do by kind of giving you a starter stub of a class similar to how it did here for our base class, our basic class. So if we right click on this class's directory that we created and we create a new item, Infringe is going to kind of give us these default Visual Studio templates, and you're going to see a variety of Kismet files as well as our kind of default UnrealScript file that we already went through. And so you've got a Kismet action, a condition, and an event. Those are kind of the three main things. There's also a UI scene which uses some of the same Kismet visualization code, but is a separate kind of editor in itself, and we won't be getting into that. Basically, if you're not super familiar with Kismet, the action, the way you think about that, or the way I like to think about it, is that an action is when you are going to act on any object in the game at runtime. So this could be an object you place in the editor, like a physics object or a trigger, even just a static mesh if you wanted to change the mesh that it's using. You can do stuff like that all through Kismet at runtime. A condition is more like your logic flow, similar to the logic flow that we've gone over in UnrealScript, such as your if statements and your if else statements and the different comparison operators that kind of exist, such as greater than, less than. All of those things are available in Kismet still, but they're kind of wrapped up into this condition block or a set of condition blocks. And then a Kismet event is when you are kind of listening for an event from the game at runtime. So an action is when you want to perform some action, manipulate some object, change something, presumably in the game state. An event is when you're listening for essentially the right opportunity to do that. So if you set up a trigger in your game environment, when when the player or a character touches that trigger, you have the opportunity to set up a Kismet event that will be listening for that, and you will get an event that fires and allows you to execute some Kismet logic at that time, which would generally be followed by a series or even just a single Kismet action that would do something because that trigger was activated. And the conditions will be kind of interweaved throughout those actions to make sure whether you want to continue down that logic path. All right, so what we're going to do is just go ahead and create a Kismet action right now. So as I mentioned, you can see that Infringe kind of set up a default class for us. It just defaulted the name to sequence action 1, which we'll want to change. And it extends the sequence action class, which is correct, and we want to leave that. I can't think of too many cases where you would actually need to have multiple kind of inheritance, so to speak, or levels of inheritance for Kismet actions. Generally, everything is going to just drive off sequence action, which gives you all of your rendering functionality and your input and output link arrays, and all you have to do then inside your class is kind of define how you want to add to or subtract from what is available to you. The thing that you're going to notice right away is that's different from the example class. I mean, we put our own function in here, but it didn't come in from the default setup. Is there's already this event called activated that's put in here for us. This is your primary kind of workhorse for a sequence action. This is what's going to happen whenever an input is fired or triggered. And you'll see the terminology has impulse used throughout Kismet actions and events and conditions. Everything has the idea of this impulse. There's inputs and outputs on a Kismet block, and either an input or an output can have an impulse. which essentially is saying it's been activated. Inside this activated event or function, it operates like a function, is where you're going to be putting your logic for what happens when your Kismet action is activated or triggered from some flow of logic. And it still has the same default properties that a normal class would have, and it puts in the defaults for you here for object name and object category. And the way these work is that the object name is going to be the actual name of the Kismet action. It'll show up in the the header of the Kismet block, as well as define the name that will be what you select in your right-click menu for adding new actions. And then the category is just that. It's a category in that right-click context menu. So let's go ahead and open up the editor now that we've created this. We're going to have to build our scripts really quickly. So we'll do that. And as soon as this is done, I'm going to go ahead and open up the editor, and then we're going to take a look at our new Kismet action, which admittedly will do nothing right now, but I want to show you how it's added it to the UI. Okay, so the editor's loaded up, and we've got kind of the default start page here, and we're going to go ahead and close that because we don't need that right now. And we're going to open up Kismet. Here in Kismet, if you haven't looked at this before, basically you have your different panes down here. By default, you'll probably have the sequence pane here, and for what we're doing, we don't really need that, so I just kind of hid that. But you've got this pane here where you can add all of your Kismet, and you've got the right-click menu. So if you right-click, you're going to see new actions. Also, you'll see an entry for Matinee, which is kind of separate from what you're going to be doing in UnrealScript. Matinee is its own editor, so to speak, and for how to manipulate objects through keyframing and stuff like that. Well beyond the scope of this. We do talk about that a little bit in the intro to Kismet. And then there's the conditions. There's a section for variables and then events. So obviously you have the action, condition, and event that you saw as the different class templates. And then variables are just that. These are the different variables that are available. Stuff that is available in UnrealScript like bools, floats, ints. And then they also have, like a custom player object, just a generic object which can be assigned different things, and the vector class. So what we're looking for is actions right now, and you're going to see that we now have this new group called Unreal E3D UnrealScript Actions. And getting a little bit of a weird UI thing here, but let's start over here. So there you go. You got this is the category and this is the name. So if we bounce back over to the script file, there you go. There's the name of the class, and there's the category that was defined. And so that's exactly what we're looking at right here. So basically, if you're adding a new Kismet action and it fits into an existing category, then in that default property, you would just edit the string that is defined there to match an existing category, such as an event or maybe an actor, or if what you're doing is operating on something with physics, there's a physics category. Basically, just whatever makes sense, or you can define your own. Like you'll see here, they have demo game, which is sort of just for demonstrating some things that you can do with Kismet, but not necessarily something that's in a shipped game. All right, so let's switch back over to the script and make some changes to this actual class. I'm going to go ahead and shut the editor down because in order to pick up the changes, we'll need to reload it after we're done making them and can compile the script. So here we are back in the sequence action class. Before we go in and actually start editing here, I'm going to open up a couple of existing objects to show you kind of what exists as far as like that base functionality that's kind of coming from the sequence action class, so that you don't spend a lot of time writing new stuff. So if we open up the engine folder here in classes, and we scroll down to the section with starting with S, you're going to see a large list of sequence actions. Here we go. So everything starts with this prefix, sequence action or action, and there's also conditions and events. The conditions are like we were talking about, the different comparisons and the logic kind of operations. So the first one I wanted to open up was the sequence action gate. This is a commonly used Kismet action when you're doing scripting logic in Kismet, because this is how you do it. This is sort of like one of your if checks that can be checking against a bool value or different values. And then the other one I wanted to open up is a comparison, and that is the integer. All right, so I'm going to drag this over here. So let's take a look here. If you look back here in the editor, you'll notice that I'm going to go ahead and drop an instance of both of these blocks, and so you can see what we're going to, what is there visually if you're not familiar with it, and so that way when we're looking through the script, you can kind of start to match some of that up mentally. So let's go back over to the editor. Okay, so if we open Kismet back up, and we'll go ahead and drop in an instance of both of these two classes that we're going to look at. The gate is located under the miscellaneous section of actions, and the comparison for ints is under conditions, the comparison category. All right, so here are two objects that we were just looking at the class files for. So I wanted to highlight a few things so that you could see these kind of in action in the script and make that connection. So the gate by default has 4 inputs. You've got the in, just the, basically activate or check this gate, and then you've got the single output. So the logic flow is to come into in and then go out if whatever condition of the gate is true. There's an internal variable called open, and this is defining whether or not this gate is a pass-through. So it's basically saying, is this true or false? So you can open or close that, and that changes the value of this open variable in the UnrealScript file that's driving this. And you can also toggle it, which will just do exactly that, toggle it true or false. So whereas if you were doing a comparison for a bool, see here you'll see kind of the opposite, where you have a single input and 1 or more. As you can see here, you have a lot more, 5, but a bool you just have true or false case. And this is going to be checking against whatever variable you pass in through here. And then it can also output a result. The gate is a little simpler in that, and it always assumes a bool case, and it stores that bool internally, and then you're just controlling it through the inputs and outputs. So kind of give you an idea what the gate's doing, and then the compare int is a single input, like we were talking about, and then multiple outputs. So these kind of are the 2 different scenarios of how the inputs and outputs are handled. So now let's go take a look at the script file. So here you have the gate. Again, you'll see that it just derives from sequence action, as we were talking earlier, you're pretty much always going to be doing. Notice that this does have CPP text, which means that it has multiple functions that are defined or editable in C++. You'll see here that this one actually does have functionality that's written here, but it's still encapsulated in that C++ text, which means it will be mirrored in the C++ code. So there might be something in this that has to take place there. And then if you look down here a little bit further, you've got the internal variables, and here is your open variable that we were looking at there. And it also has this auto comment thing. This is what was driving the comment above it, the object that actually told you whether it was open or closed. That's sort of just like an extra workflow improvement that didn't actually used to be present in some of the older versions of Unreal. And then you've got the auto close count, which is another internal variable, which I didn't talk about, doesn't really matter right now, and then the current close count. So if you look down here at the default properties, you've got the object name, just like we were talking about, the category, makes sense. You've got the default state of those 3 variables, defaults to open, and this is a comment, suppress auto comment, it's across all actions. And then you've got, right here is what we're actually looking for. So you've got these input links, and you'll notice the numerical values here, which is similar to, we talked about arrays, how arrays are 0-based. And that's essentially what you have here. You have a input links as an array, and if you hover over here, the IntelliSense kind of pops that up. So it's an array with a dynamic array that can have multiple elements to it. And so what you're doing here in the default properties is basically saying, I want to have 4 elements. You're numbering those elements, and you're also giving it a link description. So these are the 4 inputs that we saw. And then you've got the variable links here. You'll notice that this is set to empty. By default, you're going to have a variable output, variable link, I believe, that comes from just your sequence action class here. And in this case, for the gate, it doesn't need to have that. So you're basically wiping out that array, saying, I don't have any variables, I don't have any need for them because I'm tracking my own internal bools. So just clear that out so that you don't have an extra node on the Kismet block. And you notice it doesn't specify anything about the output links, and that's because by default you have a single output link that's already been labeled as out. And in this case, they don't need the gate to do anything else in that, so all they've added is the internal. We'll bounce over to the compare int and just kind of contrast that. Same deal, single this actually does derive from a sequence condition. There's a difference, but kind of the same idea with the action, that there's a single base class that they'll all derive from. And you've got the same idea here with this activated function, which is handled in C++. And then you've got these two values here, which are the internal variables. And if we bounce back over, you'll see that really quickly. These are representing these two values, these two nodes here, A and B. And so here you've got the variable links, whereas the previous class set that to empty. It's actually defining, two elements and setting the expected type to an integer, which is represented by that teal color, and then also giving it a label A and B, and then also assigning the value of it, which is these internal variables, value A and value B. And then you've got the single input link, and then you've got multiple output links. So in this case, it does specify the output links because it needs multiple of them. So we've got these input links and these output links. So how do those work? So what you have basically is this idea of an output link, because this is an object, this is a sequence operation inside that base class, and it has this variable, has impulse. Kismet is sort of running, at some refresh rate. I'm not exactly sure what the refresh rate is, but presumably once per tick or once per frame, you're going to get an evaluation of Kismet. And so it's going to be looking over all of the Kismet actions and looking for output links or input links that have this impulse set to true. And it will actually do its operations, or its code or script from based on that, and handle, the timing and what it's connected to, and activating, in this case, you're saying this output link has an impulse. So the actual Unreal side of the Kismet is going to handle firing that link, detecting what it's linked up to, what input it's linked up to, and then setting that input links has impulse to true, so that way whatever code you might have that's waiting for an activated on a particular input link will then fire either in that same frame or the next frame. So anyway, all you're really doing, it's kind of a confusing explanation, but basically what you're doing is you're not actually saying, I want to fire this output, or calling a function to fire the output. You're setting the value of has impulse to true and letting the Kismet system itself kind of manage when that is fired based on performance, and it has so many milliseconds of the frame that it's allowed to operate. So sometimes it will actually happen the next frame of execution. But right here you've got the activated, you've got some simple comparisons. In this case, since it only had the single input, they don't have to even check for which input link was activated. They just say, okay, I was activated. I've got these two internal variables. What's the status of that? A simple logic check on that. And if this tests true, then fire my output link 0, because if you look down here, that's the condition. Output link 0 was A is less than or equal to B. That's what we're checking for right here. So you fire this true, skip over, or finish the execution there, because these are not else ifs. And so you're only going to fire a single output, and that's it. So that's kind of how the comparison works. And if we bounce back over to the gate, you'll see kind of similar thing, except in this case, they're doing on the activated function here, they're checking, instead of checking for logic of internal variables, they're actually looking at the input links, because the gate has multiple input links and one single output. And so it's just checking that bool value, saying, does this input link have an impulse? Is this set to true? If so, then I need to do some logic or some scripting based on that. In this case, it's setting the open to true, because input link sub 1 is the open. So the only job of this input link is to set this bool value to true, which it's doing. You notice here it does do a little bit extra logic for the auto close count, because we didn't really talk about it, but the gate has another variable internally that you can track the number of times that it's been activated, and it will auto close itself after so many times, but that's not really relevant to this. You notice input link 1 is the one that kind of starts with here in the logical flow, and goes 2 and 3, because those all have a particular thing that they're doing basically to the open variable. And then down here at the bottom is actually the input link 0. And kind of the reason for that, I assume, is the logical flow, is that this is doing an extra check, which is checking the value of this variable. And it wants to make sure and process if it was hit with multiple inputs, which is possible. You can have multiple inputs or outputs have an impulse in the same tick of execution. So one Kismet action could be linked up to both of those. And the order does matter internally. I mean, it's all tracked internally, so you don't have to worry about it. But anyway, basically it's saying make sure and do any operations on any of the input links that would have operated on the bool before I actually do the operation to say, hey, my actual input was fired. Should I allow pass-through or not based on this variable? So we're not digging into gate. I'm talking a little bit about the logic, but it just kind of, I think, helps reinforce how the input links are working and kind of some of the things you have to take into consideration if you're going to be writing your own sequence actions or comparisons, is that things like multiple inputs can have an impulse in at the same time, and there is going to be an order to them. So things to think about when you're writing your own. Okay, so we've started up, Unreal here with after compiling our custom one, so we can see that. We'll drop this in. So again, just we have the default state, so we have a single input, a single output, and this default target variable. So if we wanted to do something specific with this, we can do that, by adding additional input links. So here we could have an input link, and we'll just leave the default sub-0, 1 description. I'm going to copy that, change its value to 1. So if we save that, and then quickly compile and reload the editor. Okay, so we'll open up Kismet now that we're back in the editor, and look for our action. Drop it in there. Not a big change, but there you see we've got 2 inputs, and the custom label on that was my custom input. So it's really now we're going to go into it. You can look at other examples of sequence actions, conditions, and events for kind of how you do more of the functionality internally, but that's a quick overview of kind of how the inputs and outputs links work, and as well as the variables. It's really all you need to know kind of as far as foundation of how Kismet works and how those are set up, and then the logic that you derive or contain inside of the activated function there is up to you, as well as you can look at some of the other actions that do some heavier lifting, we'll say, and you'll see that they do some other things, internally maybe, or some other functions, but kind of gives you the overview. All right, so that's a bit about the Kismet extensions you can do or modifications in UnrealScript. And so now we're going to look at a more, another custom class that we'll create, but I wanted to show you how you can actually take those classes and see them here when you're in the editor in the actor class browser. So you'll see that you can add your own classes, and they'll show up here based off of how you're driving them. The tree here kind of represents the hierarchy of inheritance. So fluid surface actor movable is an extension of fluid surface actor. And so we're going to go ahead and do an example of that and set up sort of a cheesy, what I'm calling a compound mesh. Not super practical maybe for games, depending on your purpose, but basically we're going to create a single mesh object class that will actually have 2 mesh components, so it can have 2 separate renderable instances, but it's all treated as one object in the editor and in the game.